Welcome to this tutorial about RJEC1's History Analysis feature. My name is Amos Egel. I am a RJEC1 developer at Hamburg Photonic. In this tutorial, we assume that you already know how to set up a basic ray tracing simulation in RJEC1. If that is not the case, please see our other video, First Steps in RJEC1. In this introductory video, we will learn what is history analysis and why it is useful. So, what does the word history analysis mean? In RayJack1, after ray tracing, all rays are in the final state, which means in the state of their final interaction. That could, for example, be the absorption by some surface. If we want to know what has happened to the rays before they were in the final state, we can use the so-called history detector. The history detector is a database of ray interactions. If set up accordingly, the history detector records all ray interactions from creation until the rays are stopped. By history analysis, we mean an analysis that is done in post-processing after the ray tracing and that makes use of the data from the history detector. One of the most important examples of history analysis techniques is the so-called path analysis. Why is history analysis useful? Basically speaking, history analysis helps to make sense of ray tracing results. Whereas other detectors may tell us how much flux, irradiance, or intensity arrives at some detector surface, the history detector can help us to understand why. Consider, for example, this toy model of a telescope. It is illuminated from the left by a rectangular collimated grid source. The rays propagate through the first lens and then through the second lens before they are absorbed by a screen. The irradiance distribution on that screen is given by the nominal light of the light source through the telescope. The interpretation of this irradiance distribution is straightforward. However, if we set up RayJack1 to not only simulate the nominal light path, but also to consider split events during ray tracing, the resulting irradiance distribution is more involved. In addition to the pattern from the nominal light, we can see secondary light patterns, the so-called ghosts. They emerge from multiple reflections in the optical system. One ghost is visible as a dilute background in the lower half of the irradiance distribution. Another ghost is visible in the shape of sharp features at the bottom part of the irradiance distribution. The data from the irradiance detector tells us that these ghosts exist, what shape they have, and how strong they are. However, it does not help us to understand where these ghosts come from. And this is where path analysis comes into play. With the help of the history detector, we can, for example, study with what other surfaces the rays have interacted, which then contribute to the ghost at the bottom part of the irradiance distribution. In the following videos, we will give you a step-by-step guide how to apply history analysis in your RayJack1 projects.